Are you using Azure Purview, and do you want to take advantage of the column mapping feature inside of your own custom types and entities? Then this is the video for you. In this video, we're going to cover how Lineage works very briefly. We're going to cover how column mapping works in Purview. We're going to create an Excel template as well as a custom type that takes advantage of the column mapping feature. Then we're going to see a little bit of code that allows you to update an existing process entity, assuming it already has the column mapping attribute. Or we're going to create lineage and column mapping at the same time through Excel. By watching this video, I'm assuming that you're more of an advanced user, so I'm going to briefly go over Lineage. In general, Lineage in Purview and ApacheAtlas is all about the process entity type. And the process entity type has an inputs and an outputs attribute, and those also correlate to two different relationship attributes as well. The inputs and outputs can only be of type dataset or any other child type. So long as you are using a dataset type or a child of it, you can have that represented as an input or an output. That means you cannot use assets or any other infrastructure types. Those will not be allowed to be used inside of the entity of process type. The real crux of this column mapping is only in Purview. So this is again specific to Azure Purview. Azure Purview invented this concept specifically to create a feature in the user interface on the Lineage tab. The way column mapping works in Azure Purview is that a process entity type has a column mapping attribute. That column mapping is lowercase c, capital M, all one word. And so a column mapping attribute is a string that is a stringified JSON object. And it is specifically an array which contains one or many JSON objects. And that object has a key of dataset mapping and another key of column mapping. The dataset mapping is the easiest one. It is strictly just talking about another object. The value of the dataset mapping key is another object in which you have a source key and a sink key. And those sources and sinks are the qualified name of the input and output dataset that you are using in your lineage. So if you have an input called with the qualified name of input A and an output of output B, then your dataset mapping would look like, curly braces, quotes, source, then the input A as your source qualified name, and then comma, sink, and then in quotes, of course, the output B as your sink. So that's a nice dataset mapping. Column mapping is a little more complicated in that it is the individual columns, and it is, again, a key of column mapping, and then it is an array. The value is an array of individual objects that are, again, source and sinks. And so the source and sinks now are not related to the qualified name, but they are related to the column name. One of the big tricks that I see with people using this column mapping feature is that you have to maintain this yourself. There's nothing inside of Azure Purview that will rebuild this column mapping for you, except for the built-in tools like Azure Data Factory and I believe Azure Data Share. Those will create new entities or update this field for you. But if you're doing this in a custom set, in a custom type, or a custom entity, you are responsible for keeping these source and sink columns and dataset mappings as well correct and up to date. So again, column mapping is an array of objects with a source and sink, and this can be anything. Even if you have no schema attached, no columns attached to your entity that you're using as an input and an output, it can be free-form text essentially. So that makes it very, very powerful, but also makes it a little more challenging in the sense that you, again, have to maintain it yourself. Again, assuming that you are an advanced user, I'm going to skip ahead. If you need to create the template, you just run this command, python-m PyApacheAtlas -make template, and then give a path to the template name. Now that we have a template, we can create a custom process type for column mapping. And really that just means we need to have a column mapping string attribute. So you can do this in code or you can do this in the Excel template. So I will quickly show how this would look on the Excel template. Here I am on the Entity Defs tab, and I am looking at a set that I've just kind of pre-filled in, and I've given this a entity type name of custom process with mapping. So that's the name of my type. And then I've added a column to the template, which is a special header. It's entity super types, and that allows me to specify what is my type inheriting from. By default, it is dataset, but since we are working with a custom process type, we need to add in this entity super types column to the template and add it with the words process in there. Next, I'm going to use the name column, and I'm going to say this is the name of an attribute. I'm going to call it column mapping because this is the key attribute that Azure Purview UI looks for. So you must have a column mapping attribute on your custom process type. And then finally, I'm just going to give it some description to give it some information. So great. Now that I've done that, my Excel template is ready, at least for creating that type. Before we get into actually uploading the type def, let's talk about the parse column mapping function inside of the Excel Reader class. This would allow us to parse the column mapping tab in the Excel template, and it would produce a process entity given our custom type name that we provided in the Excel template, and then it would also produce that stringified JSON inside the column mapping attribute. In the Excel template, we have these few columns that we need to fill in. So first, we need to provide the source qualified name. So again, that is the data set. That is the data set that is going into the process. And so in my case, I have demo input 01, 02, and I'm going to then also have a set of source columns. And I'm going to make this kind of tricky. I'll have demo input 01 with source A, input 02 has source B, input 01 is going to have source C1, input 02 is going to have source C2. And they're all going to go to the same exact target qualified name. And so I'm taking two tables, two data sets, and I'm going to push them into one particular table. And now, again, these couple of steps here, you must have them in existence already, right? The source qualified name, the target qualified name, those should exist already because it's going to assume that they exist when making the upload. Given these source and targets that exist already, we can also look at the target columns. So source A is going to go into target A, source B is going to go into target B, and then I'm going to represent how source C1 and C2 can be both quote unquote combined into target C. Now that I have that done, we can go into the actual process that's being used. So I'm just creating some sort of silly qualified name for the process entity, and then very importantly, I'm using my custom process with mapping type. And the reason I'm doing that is because I must have a process type that uses the column mapping attribute. And then finally, I'm giving it a silly little name for the process name. So great, I could use this, and I could, assuming that the entity already existed, then I could just use this to push up this new updated column mapping information to it. More likely what you're going to be doing is you'll be probably creating an Excel spreadsheet with both the inputs and outputs for the process entity, as well as creating the column mapping at the same time. Usually customers are using PyApacheAtlas for either big bulk uploads initially or regular routine maintenance as well, and often adding in brand new things. So I also created the parse update lineage with mappings method. This method will take the inputs from both the update lineage tab as well as the column mapping tab and combine them at the same time. What does that do for us? Well, that allows us to also update the inputs and outputs of the process type at the same time, and gives us the column mapping as well, as you would expect. So this gives us the best of both worlds and keeps our tabs in Excel nice, neat, and orderly. We can update our lineage in one, we can provide all the inputs and outputs there, and then we can specify the columns in another tab. And so long as those two tabs are correlated, they share information about the targets and the sources, as well as the process types and things like that, then we're all good. So let's take a look at what that might seem like. You will see in the Update Lineage tab some very familiar names, right? My target qualified name is demo output 01. My source qualified name, I have two of them, input 01 and input 02. And then very importantly, I have my exact same qualified name for the process and the exact same type name as well. With my Excel spreadsheets all taken care of, now I'm going to run some demo code to actually parse those tabs and then do some uploads. So first here, I'm going to create my custom type. I'm going to parse my entity definitions that we set up in the beginning with my custom type, and then I'll upload it. Then I'm going to, in the very next step, I'm going to parse that update lineage with mapping, so both the update lineage tab as well as the column mapping tab. It will merge the information together and produce one output of processes. And then I'm going to go and upload those results as well. And great, we have successfully done a GUID assignment. It's a create because I'm creating this process type for the first time. So let's go and browse and see if we can find that particular process entity. And now, just like that, we have a custom process with mapping, and we can go on our left-hand side and actually see the individual source columns and output columns as well. And so I can see that source A correlates to target A, source C1 is with target C, source B with target B, and source C2 with target C. And great, and there's the cool little features of there. I can also switch this to output data sets and then see the reverse as well. If we check out on properties, we'll see that the column mapping attribute is here. And we have, it all looks awful and crazy inside of here, but this is the key feature that allows us to actually render this information on the lineage graph. And with that, thank you so much for watching. I appreciate your time learning about the column mapping feature within PyApacheAtlas. If you have any questions, comments, or concerns, please feel free to leave a comment or reach out on GitHub and place out an issue. Thank you so much.